Good morning, ladies and gentlemen. This is a voice from your not-so-distant past. That's right, Mr. Eicher still lives, surviving the flu, sitting at home, wondering how you're doing on your homework tonight. So here's a video, just addressing a couple of the key concepts on the 8.1 packet. I will ask your forgiveness if I cough in the middle of this video, but I'll try to not be contagious. So in this chapter we're talking about quadrilaterals. You can tell that I'm very slow to speak. My mind has not yet caught up. On this first page, I wanted you to prove why the interior angles of a triangle add up to 180. Hope you remember how to do that. I'm not going to explicitly cover that right now. This diagram is very important for you to understand. Every quadrilateral has interior angles that measure 360 degrees. And the basic idea is you can divide any quadrilateral into non-overlapping triangles. When I say non-overlapping, I mean don't make triangles that look like this. That would be triangles that have vertices as corners on the quadrilateral, but then there's overlap there, so you don't want that. So one vertex to another vertex, here are two triangles, so you don't need any more triangles. But why does it add to 360? Well, if one triangle is 180 and the other triangle is 180, then you know that all these angles, this whole angle here, this whole angle here, this whole angle here, and this whole angle here, all adds up to 180. And you can see on the next page, you have a pentagon, adds up to 540. Well, hopefully this makes sense. If you have three triangles, right, three triangles, and they're all 180 degrees for the interior angles, you can do 3 times 180 degrees equals 540 degrees. In the table below, I try to walk you through to discover for yourself the formula. I believe that this table is in the book, so you don't need me to fill out this table for you, since you can do it yourself. This theorem is going to be very important in this in the lesson today. That's not a very long lesson today, since you've already done this packet. But what you should have discovered from this table is that the sum of the interior angles of any N-Gon, n-sided convex polygon is 180 times n minus 2, where n is the number of sides the object has. So in this formula, the 180 is from that idea that we were developing about triangles. The n minus 2 is how many triangles, the number of triangles that you have for each given shape. So if you have a shape with n sides, you can make n minus 2 triangles over it. Multiply by 180 and you get the sum of all the interior measures. And then you can answer these questions. See if I can answer these. The sum of the measures of a 20gon, 20 sides, minus 2, according to the formula, That's how many triangles you have. That's a triangle. Times 180. I don't have a calculator, you do. That's the sum of all the measures. Notice this question though. What is the measure of each angle of a regular 20-gon? If you want each angle, you'd have to take your 20 minus 2 times 180. That's the sum of everything. And then you divide by the total number of sides that you have, which is 20. And that will give you how much one angle is, one interior angle. Letter C, we just work backwards. If the sum is 5040, and the formula has 180 for one triangle, how many sides? You have n minus 2 in the formula. And then solve. Divide both sides by 180. And whatever that is, add 2 to both sides, and that's n. Letter D. I'm sure there are multiple ways that people may have thought to do this. One idea that I had is kind of to use this formula up here that we had. How many sides? So you're solving for n. A regular polygon, one interior angle. If one angle is 157.5, you would take the sum of all of the angles, n minus 2 times 180. Divided by n. And solve that. To solve that, you'd want to multiply both sides by n, and then distribute this 180. You're going to have an n on both sides, but I trust your Algebra 1 skills that you're able to solve that. I'm not going to go through these. You can ask your neighbor, see what answers they got for these. Very important though, conjecture, number 11. Conjecture about the exterior angles. The conjecture that we have, hopefully that you noticed from all these questions above, the exterior angles always, for every convex polygon, add up to 360 degrees. And we can use that to answer these next 3 questions. The sum of the measures of the exterior angles. Well, the 1000-gon doesn't really matter because every N-gon has a measure of 360 degrees for the exterior angles. If it asked the interior angles, that would be something very, very different. You'd have to use our original formula. The sum equals n minus 2 times 180. But you weren't asked to do that. What is the measure of each interior angle of a regular 15-gon? Now listen closely on this one. Nice shortcut here. Remember on the last page we had to answer a question like this. That was this question over here, 7D, that question right there. Had to use a little algebra. Not too bad. However, on this question, using what we know about exterior angles of convex polygons, can actually make our work a little easier. Let's find an exterior angle first, just one of them. You know that the sum of all the exterior angles is 360. Divide by 15. Well, let's see. 2, 4. I think I did that right. 24 degrees is an exterior angle. So I'm not going to try to draw a 15-gon, but you can imagine this being one of the exterior angles right here. And right in there is 24 degrees. How could we find the interior angle then? Well, notice this is a straight angle right here. A linear pair. This is 24. 180 minus 24 is 156. That's right. So this answer is 156 degrees. Interior angle of a regular 15-gon. So just to recap that, first we find the exterior angle. Use this formula right there. And then do a little subtraction from 180. Finally, letter D, which suspiciously probably should say letter C. Sounds complicated at first. One exterior angle is 300. Sorry, one exterior angle is 30. We know that all of them are 360 degrees. So if we divide by 30 degrees, that would give us 12. This is a 12-sided regular polygon, known as a dodecagon. Decagon for 10 and do for 2. On to the notes. You should have already written this theorem down in that packet, but it might be helpful to have it written in your notes. Make this bigger just in case. Interior angle sum theorem. You could also write it as the sum equals 180 n minus 360. Uh-oh. Oh good, I didn't run out of space. I usually write it like this though. The second theorem, the exterior angle sum theorem, you should also have written in that packet that you did last night for homework. The answer here, the exterior angles, so any kind of convex polygon, 1, 2, 3, 4, 5, 6. So this is a hexagon, not a regular hexagon. But if you count all the exterior angles, this one, that right there, this right here, this right here, this right here. All those exterior angles, they add up to be 360 degrees. Always. For every polygon. Amazing. So I would like you to answer these 4 questions. If you would pause this video, take time to answer these, and then very soon, spoiler alert, I will show you the answers. So pause this video. And here are the answers. With a little work shown. Notice on this question, I decided to find the exterior angle first, which was 30 degrees, and then do its supplement, 150 degrees for the answer. Number 3, it's important that you're told it's a regular dodecagon. Dodecagon having 12 sides. Because, as my really bad handwriting says, if it's not regular, the interior angles would not be congruent, and you wouldn't be able to find each interior angle. You'd have to know a lot more. But if it's regular, then they're all the same, so they would all be 150 degrees, as number 2 said. And notice on number 4, I also chose to find the exterior angle first. So the interior angle is 135, that makes the exterior angle 45, and 360 is the sum of all the exterior angles divided by 45 is 8-sided, so it's an octagon. Last 2 questions I'd like you to try. Please pause this video. You can work with your neighbor, try these, and then I'll show you the answers very soon. Bingo, there it is. Number 5, 360. Exterior angles, the sum of all of them is always 360 for every convex N-Gon. And number 6, exterior angle, they all add up to 360. You're told the number of sides, divide by the number of sides, and you get whatever that answer is. I don't have a calculator. Thus ends going over the homework and the very brief lesson. Please take the rest of class, work on the homework, make sure you get it, find someone in class who gets it. And I hope to see you tomorrow. Have a great day.